Still going live. I'm live. Excellent. For those of you in the live stream, just a brief rundown of what's going to be happening today. Number one, I'm going to be talking about stolen bases. I'm going to be talking about the different dimensions of the baseball field and some calculations that we are going to have to do and write into our notes in preparation for an assessment that I'm going to be giving you guys tomorrow on Google Classroom. Now, this assessment, you'll have plenty of time to get done. It'll be due Friday of next week, but we'll talk more about that when the time is appropriate. After the calculations that we're going to have to do, I do have some videos to show you in regards to the man, the myth, the legend, Rickey Henderson, which relates to what we're doing here. And then we're going to wrap up with our home run hitter debate in order to see who is going to make it to the next round. Okay. In 2020, you can't really count this because 2020 was an anomaly year. 2020, they only played 60 regular season games, so ignore those numbers. But what do you notice about the previous bunch of years of the season stolen base leader? This is the leader in stolen bases just in the American League. Where do these numbers typically average out at? 40? Yeah, probably like 46, 45, 34, 43. There's a 56 randomly about Altuve, you know. Let me go down to the National League then. Let me flip down to the National League and let me just flip to the last couple of years here. Here we go. Recent years. A little bit higher. A little bit higher. But like somewhere in like, the 60s. So maybe the 40s for the American League, 60s for the National League, averages out at 50. Let me ask you a question. If you steal an average of 50 bases a year, how many total stolen bases would you have after 20 years of playing? If you average 50 stolen bases a year, how many stolen bases would you have after 20 years? You'd have 1,000 stolen bases. Now, 1,000 stolen bases, interesting. 1,000 stolen bases is interesting. I'm going to show you what this thing looks like in a minute. But keep in mind, those 1,000 stolen bases assume that you will continue stealing bases. What kind of athletic ability do you need to have to steal a base in baseball? You got to be fast. And then after the course of 20 years, what's going to happen to your body? You're going to slow down. It's going to break down. You're going to get injured. These guys are getting roughly 50 stolen bases a year. The league leader is getting 50 stolen bases a year today. If they were to average 50 stolen bases a year for 20 years, you said it'd be 1,000. Yes, I agree. What if they played for 25 years? 25 years, 50 stolen bases a year. How many is that? You got calculators on your thing? Not quite. 1,250. 25 years, 50 stolen bases a year, which, by the way, 50 stolen bases a year today you'd be at the top of the list. You'd be the best stolen base guy in the league. You would be fast. You would have to stay uninjured. The older you get, you would have to maintain your level. That's tough. That is very tough to maintain a level of that caliber, and you would have 1,250 career stolen bases. 1,250 career. 25 years in the league, meaning if you started when you were 20, you'd be done by the time you were 45. But most people don't start when they're 20. At what age are most rookies in baseball? 23, 24, 25, mid-20s really, right? You played for 25 years, you'd be almost 50 years old and still having to lead the league like that. Check this out. Here's the career list of stolen bases. This isn't even a contest anymore. Rickey Henderson is an alien. Rickey Henderson is not human. Rickey Henderson not only blew past that number, averaging over 50 stolen bases a year for 25 years. Not only that, somebody do the calculation real quick. What is 1406 minus 938? It's in the 400s. 468. The difference between Rickey Henderson and Lou Brock is 468 stolen bases. I need to put that into context for you. If Ricky Henderson only had 468 stolen bases, he would still be top 50 all time. Still be top 50 all time. That is insane. The man is a legend at what he does. Now, our goal today is to do some calculations. How much time does someone have to steal a base? Where's the little wiggle room in between? If a pitcher's throwing the ball home, the catcher gets the ball and throws it to second base. We'll focus on second base for now. How much time does a human being have to steal a base? Ladies and gentlemen, if you would, I'm going to need those notebooks out and open. By the way, let me show you something about Ricky Henderson. There's Ricky Henderson's Wikipedia page. On everybody's Wikipedia page, it shows you all the teams that they played for. Check this out. Look at Ricky Henderson. He started out playing for the Oakland Athletics. Then he went to the Yankees. Then he went to the Athletics. Then he won a World Series with, he won a World Series with the Athletics in '89. Won a World Series with the Blue Jays in '93. Then he went back to the Athletics. Then he went to the Padres. Then he went to the Angels. Then he went to the Athletics. Then he went to the Mets. Then he went to the Mariners. Then he went to the Padres. Then he went to the Red Sox. And then he finished up with the Dodgers. I have no idea. But apparently they found value in him. They found value in him way into his 40s. The dude is not human. Anyway. So let's talk about this. This is stealing a base and the science behind it. Now, I'm basing this on a video that ESPN did, but I redid my own calculations. Because I wasn't really satisfied with what ESPN did. I wanted to go a little bit deeper. Get this. So, first of all, let's talk about a baseball diamond. Now, this is obviously not going to be perfectly to scale, but we'll deal with it. Here is the infield of a baseball diamond. Now, we're talking about stealing first base, running to second base. Just for the sake of argument, how many feet is that? It's 90 feet. You got 90 feet. Now, yes, you got 90 feet, but what does a base runner typically do before the pitch is thrown? They take a lead. Yes. Now, approximately 12 feet. Yes. You watch the video too? Never mind. So, a base runner typically takes a lead of 12 feet before they start running. So, if they take a lead of approximately 12 feet, that means that they have 78 feet to go. Now, a very good base runner, or I'm sorry, let's just not very good, let's just say like a decent base runner will run approximately 15 miles an hour. Approximately 15 miles an hour. Compare this to like Usain Bolt. Usain Bolt, like fastest human alive, runs over 20 miles an hour, just for the sake of argument. So a base runner is going to be running at 15 miles per hour. So the question becomes, if he's running 15 miles an hour and he has to run 78 feet because he's taking that lead, mind you, how long will it take a decent base runner to reach second base? How long will it take a decent base runner to reach second base? We're going to have to do a little calculation thing here. Say again? No. No. I need accuracy here. Check this out. Here's what we're going to do. We need to do a conversion here. All right. We need to do a conversion here. Now, the conversion that I need to do is something like this. And this is going to be very helpful for you moving forward. The conversion is this. 15 miles an hour. We need to convert that to feet per second. We need to convert it to feet per second in order to do what we need to do. How many feet are in a mile? Oh, 5,000. There you go. Yeah. So check this out. 1 mile is equal to 5,280 feet. Now, this scientific conversion is going to come in handy for what we need to do later on. This scientific conversion. Technically, now you just said it. You said 5,280 feet is equal to 1 mile. So technically, I'm not changing the value of this number. I'm just changing the units. What happens when you take miles and divide them by miles? Think about like the variable mile divided by mile. What happens? They cancel each other out. But the numbers remain. Now I don't have miles per hour. Now I have feet per hour. I got to convert an hour now. 60 what? 1 hour is equal to 60 minutes, in which hours would cancel. Oh no, it's going to be a reason. You'll see. And now I got to convert minutes because I need feet per second. Say again? I didn't hear it. Oh, I got to put 60 down here for 60 seconds and 1 minute, right? Now look what we're going to do here. This is the first time you're seeing a calculation like this in this class. Maybe you've seen something like this in a science class before. Something like that. Yeah. But this is a basic conversion of units. A decent base runner is going to run at 15 miles an hour. Decent. So I got to convert that to feet per second. I multiplied it by this because these two things were equal to each other, canceling out the miles. I multiplied these two together to cancel out the hours. I multiplied these, multiplied by this because it canceled out the minutes. What are the only two units left over? Feet per second. So if I do this calculation correctly, it should give me what I'm looking for. Now, of course, you do have the calculators on your Chromebooks. You don't have to pull them out now. That's not the purpose of this. I could do something like this very easily. 15 times 5,280 divided by 60 divided by 60. You can literally type it in all in one shot. 22 feet per second. Now, this is going to be helpful. The question was, how long does it take for the runner to run those 78 feet to reach that base? Do you guys know the distance formula from science? I mean, it could be speed. I've referred to it as a different word, but we could use the word speed. Velocity. I was thinking rate. Distance equals rate times time. Distance equals rate times time. You ever heard it's called, I refer to it as the dirt formula. D equals RT. Otherwise known as D equals RT. It's the dirt formula. The distance that he's trying to travel is 78 feet. The rate that he's running at is 22 feet per second. Somebody do this calculation for me. What's 78 divided by 22? Round it to 2 decimal places. 78 divided by 22. Nobody wants to do it. They're afraid. Several of you have calculators on your phone or on your computers. Huh? Well, round it up, I believe. It goes 3.55. Yes, but then that 4, because of the 5 after, rounds up. I don't know where you got. I think you might have inverted your numbers. Yeah. 3.55 seconds. So now the question then becomes, okay, how long does it take a decent base runner to run to first or to second base, to steal that base? He's going to be leading 12 feet off the base. He's going to be waiting for the pitcher, and then boom, he's going to go and he's going to run to second base. It takes him approximately 3.55 seconds to get there. Now here's the question. When does the runner start running? It definitely depends on righty or lefty. What are you going to say? No, I agree. Let's just say he averages that speed. Say again? First move on the what? Okay. Let's just assume, doesn't matter the righty or lefty. Let's just assume the first move on the pitcher. Okay? When the pitcher begins the motion, let's assume the runner starts running. So now think about this pitcher. This pitcher has to begin the motion. This pitcher has to throw the ball. The ball has to reach the catcher. The catcher has to obviously know that he's going to throw to second, has to begin his motion and throw that ball to second base. Now, assuming everything goes perfectly, assuming everything hits exactly where it needs to go. The pitch was right to the catcher. It wasn't fouled off or hit or anything like that. The ball was thrown directly from the catcher to second base. Or second baseman or shortstop are in position, probably the shortstop, to get the catch. How long does it take for the ball to get from the catcher to second base? What's the like not an amazing speed, but what's like a decent speed for like a pitcher? 95. Let's go with 90. Because 95 is like you're pretty high quality. Yeah, 90 miles an hour. Yeah. Who's the fastest pitcher in baseball right now? Thank you. How fast does he average? Yeah. I'm going to go with 90. Trust me. Trust me. If you're throwing 95, if you... Not a guarantee. Not a guarantee. Hold on. Average pitch speed MLB. 90.9.
Yeah, it's still above 90.
Yeah, then there's an average of 92. Obviously, it depends on the season. Because they're not 95 miles an hour pitches. If you're throwing 95, you're a step above everyone else. It's not throwing curveballs, which are slower, or change-ups, or sliders. Let's go with 90.
I feel like when I watch baseball, it's like pitcher 98.
That might be the starters. That might be like the high quality guys. So now, go back to your baseball diamond. Go back to your baseball diamond. I'm actually going to draw a new one. I would suggest that you draw a new one as well. Draw a new one as well. First, the pitch has to be thrown to the catcher, and then the catcher has to throw it to second base. So there are two things that have to happen. The pitcher has to pitch the ball, and the catcher has to throw it to second. Hey, what's the difference between, or not the difference, what's the distance between home plate and second base? Home plate and second base.
Probably 20 feet. Oh, no, I thought you meant the pitcher. Nah.
Would you agree it's 90 feet on this side?
180.
Would you agree it's 90 feet on this side?
180.
What's the angle right here? 90 degrees.
So half of 180 is 90.
You ready?
So it's 90.
Are you ready?
90 squared is... How does 90 squared? Now look, A squared plus B squared equals C squared. I told you. 90 squared plus 90 squared.
Write it down, ladies and gentlemen. Or it's just gentlemen in this, actually. 90 squared plus 90 squared equals c squared. C squared is the distance from home to second base. You go 90 squared plus 90 squared. It's 16,200 equals c squared. You got to square root that number. You square root that number, and the distance, and I'm rounding, is approximately 127.28 feet. That is the distance from home to second base. I understand what you guys are saying, like 90 and 90 and 180 and all that stuff, but I think you said like 120 something. Yeah. But that's the approximate distance that we're going. Anybody know the distance from the pitcher's mound to home plate off the top of your head? 60 feet, 6 inches. We're going to go 60.5 to make it easy for our calculations. It's 60 and a half feet. You would think, but these are the numbers that they set out way in the beginning. So this is 60.5, and this is 127.28. Now, these are important for us to recognize here. Now, watch this calculation. This is really insane. First, the pitching motion. The pitching motion, on average, takes about 0.8 seconds. The pitching motion. Then, let's say 90 miles per hour pitch on average. We're going to have to figure that out in a moment. We'll figure that out in a moment. Then, the catcher has to try to do the throw, which his motion on average is a little bit slower. Takes him about 0.9 seconds. And now I actually looked this up. I had to Google this. A catcher throwing from home to second on average is an 81.8 mile per hour throw. And we have to figure out the total time now. In a moment, obviously, because we need to figure out how long does it take the 90 mile an hour pitch to go the distance from the pitching mound to home plate, and how long does it take the 81.8 mile an hour throw to go from home to second? We're going to have to do another conversion. Now, the conversion that we are going to do, I'm going to write this on the board over here just for the sake of argument. 90 miles per hour. It's the same exact conversion, by the way, because you're going to want to go feet per second. You okay? You keep looking back at people and smiling. It's really strange.
How can you know from smiling?
Somebody explain it to him. Anyway. 1 hour is 60 minutes. 1 minute is 60 seconds, and 5,280 feet in 1 mile. This is the conversion that we're going to have to do. It's the same conversion. You multiply by 5280, you divide by 60, you divide by 60. It's the same exact conversion. We're going to have to do that for 90 miles an hour. We're going to have to do that for 81.8 miles per hour. Let's do it for the 90. The one at the bottom? Now, mind you, I don't know what level of science you guys do that in. Do you guys know what science class you do that kind of conversion in? Chemistry? Hmm. The what? Well, it's like unit conversion is basically what this is. The basic kind of unit conversion. In physics, you might do this a bit. Yeah. Okay, whatever. Anyway, 90 times 5280 divided by 60 divided by 60. I know this looks very intimidating right now to kind of look at something like that, but since it's the same kind of calculation every single time, eventually you guys will get used to it. That's how many feet per second a pitcher throws at. Feet per second. Distance equals what? What does rate times time? Now again, the conversion is going to be the same every single time for miles per hour to feet per second. This is going to give you 132 feet per second. You will get used to this because we're going to do it over and over and over again. 132 feet per second. You said distance equals rate times time. You need to know that formula. Distance equals rate times time. Well, the rate's 132. What's the distance from, oh, you already said it. The distance from the pitching mound to home plate is 60.5. Whatever 60.5 divided by 132. Zoom in a little bit. 60.5 divided by 132. Yeah, there it is. I'm going to have to write that down. 0.46. That's how many seconds? 0.458, yes, but I'm rounding it up. I'm rounding it to 2 decimals.
Oh, okay.
Yeah. So 0.46 seconds is what it rounds to. Now, the catcher is throwing slower. The catcher is throwing slower and at a longer distance. Same exact formula. Watch what I'm going to do for the catcher now. Ready? I'll zoom in on the calculator a little bit here. So the catcher is 81.8 times 5280 divided by 60 divided by 60. You type that in all at once. Chapow. That is how fast that's how many feet per second that the catcher's throwing at. Feet per second. Let's round that to 120. I think it'd be safe to round that to 120. If you wanted to go, let's go 119.98. Yeah, I'll go 119.98. So, or no, 97, whatever. Fine, 120. Fine, we'll go 120. Again, distance equals rate times time. Distance divided by that rate of 120 gives you approximately 1.06 seconds. Let's just see what happens for a second. Hold on. Now, first of all, let's just recap what happened. First of all, these distances we're able to figure out. You can figure out the distance from home to second by a quick Pythagorean theorem. This is just information that's given to you. You said 60 feet, 6 inches? Yeah. Oh. Interesting story about Ted Williams. Ted Williams, one of the greatest hitters in baseball. He went to war for a few years during World War II, so he missed a bunch of seasons playing for the Boston Red Sox. So he missed out on like the prime of his career. He comes back. He walks onto the field. He immediately turns around and says, something's wrong. They better fix it. And like, what are you talking about? He's like, the pitching mound is off. He's like, the pitching mound's off? So they went out and they measured it, and they found out that the pitching mound was like an inch too high, just an inch too high. Ted Williams saw this just by walking on the field, looking at it, and turned right around and said, nope, you got to redo that. Because every inch that the pitcher mound is higher, the pitcher has the advantage. Regulation, they had it off. It was crazy. This guy just saw it after 5 years of being away. Insane. Anyway, this total right here, the pitching motion. So the pitcher begins his motion. The runner starts running. The pitcher begins his motion, takes 0.8. 90-mile-an-hour fastball takes about 0.46. The catcher gets the ball, begins his motion, 0.9. Throws it to second base, 1.06 seconds. Assuming that the throws are both on target. How do you know? Let's see what happens. So we got 0.8, 0.46, 0.9, and 1.06 adds up to 3.22 seconds. The runner takes, what did we say, 3.55. The throws take 3.22. According to this, the runner should be out if everything goes to plan. But here's the thing now. The throws are not always on target. Sometimes the throws are high and they got to bring the ball down. Sometimes the throws are a little bit off to the left and the right. Sometimes the catcher takes an extra fraction of a second to throw the ball to second base. Sometimes the runner got a good jump. These are all different little things that come into play. All different little things that could affect the outcome of the guy stealing the base. Stealing a base literally comes down to a fraction of a second. It is absolutely insane how tough it is to steal a base. Now, on everybody's stat sheets for baseball players, you'll either see like a total for stolen bases, and you'll see next to it, I believe, a total for caught stealing. Every runner has a certain success rate. That success rate is what, 0.33 seconds? How long is 0.33 seconds? How long is it? Done. 0.33. That's literally how much time they have to tag the runner or for the runner to be safe. It is a difficult thing to steal a base, especially if you are facing top talent. Now, I know. So caught stealing. No, but seriously, doing that takes a fraction of a second. And he's out every time? Most of the time. A good base stealer is successful what % of the time? There's differing opinions on this, but a good base stealer is successful what % of the time? It's roughly 2/3. Would you say? Yeah, roughly 2/3. How good was Ricky Henderson? Let's look at his stat sheet. Now, mind you, this isn't just over one season. This is over 25 years. Well, you're a little bit slower then.
That's insane. You would have been safe.
He would have been safe.
Absolutely insane.
Let's go to Ricky Henderson's career stat sheet right here. Hold on. Career stats. That's postseason. I want regular season. There we go. So look at Ricky Henderson's stat sheet. First of all, he started playing in 1979. His second year in the league, he stole 100 bases. What was the average today? 50 or 60. He stole 100 second year in the league. Then he stole 56. But do you know what happened in 1981? It was a strike-shortened season. The season was shortened because of a strike. Yes. Well, no, not a protest. The players, the players didn't agree with the player agreement that they had with the league, so they struck in order to get better treatment and better pay. Yes. Same thing happened in 1994, but in 1994 they didn't hold the World Series. But anyway, then he stole 130. Then all these other years happened. Now, caught stealing is right next to it. So these numbers all the way down here, there it is right there. Boom. He stole 1,406 bases. He was only caught 335 times. Now, the crazy thing is, like, 335 times is actually like the major league lead in the most times ever caught stealing in a career. It's insane. But somebody do this calculation for me. Hold on. What is 1406 divided by 1406 plus 335? First of all, what is 1406 plus 335 by itself? It's like 1741. So what is his success rate? 1406 divided by 1741. Not 0.279 now. 0.81. He was successful over 81% of the time. 8 times out of 10, he was safe. It is. Because a good base stealer, as you just said, is roughly 67%, 2/3 of the time. He was over 81% of the time successful. It was insane. You know, we talked about Barry Bonds and the number of times that he walked. Did you know that Ricky Henderson has the most career walks if you don't count intentional walks? Yeah, if you don't count intentional walks, he got walked the most. He also has the most career runs scored out of anybody in the league. But think about Ricky Henderson and runs scored. If you steal a base, you're putting yourself into scoring position. Now, I have a video that I want to show you that kind of outlines the science that we just did. It outlines the conversions that we just did, which these conversions, these calculations, you're going to have to do on the assessment that I'm going to be giving you. Oh, he did that a lot too. We'll talk about that. Hold on. Not exactly. Let me pause this actually real. Oh no, let me get through the advertisement, then I'll pause it.
Don't you want your pocket of America to still feel like its own?
Skip. Okay. Here, write this out real quick while I talk about Ricky Henderson. Ricky Henderson stole third and home a lot as well, which they're going to talk about. Here, he stole home and third a lot more than a lot of people would imagine. Now, stealing home is incredibly difficult. If you think about stealing home, not only do you have to get like a good jump, but you have to assume that the pitcher's going to be a little bit off target and you can slide underneath. Because the pitcher, think about where the ball has to go. The ball is just going to home plate. It's not going to home plate and then to second base. You know what I'm saying? Then if you're throwing to third base, similar calculation, except you're not going 127 feet. You're only going 90. It's even more difficult to steal it. The easiest base to steal is second, then it's third, then it's home. Let's watch this.
To break down the split seconds involved when a base runner tries to steal second, we recruited Red Sox catcher Jared Saltalamacchia. I hate when a guy steals off me, period. A base runner with a 12-foot leadoff can get from first to second, averaging more than 15 miles per hour, in 3.5 seconds.
Now, they calculated 3.5. I would argue that my calculations are a bit more accurate. I'm putting it at 3.55. It's nitpicking, I know, but I like my calculations better.
From the stretch, a typical pitcher's throwing motion takes 0.8 seconds. The average 91-mile-per-hour fastball reaches home in 0.45 seconds.
I got 0.46.
It takes the catcher roughly 9/10 of a second to get off a throw. And if the ball leaves his hand at 90 miles per hour,
which, again, what catcher is throwing 90 miles an hour? I'm sorry. No, my calculation is more accurate. It's actually closer to 81.8.
It'll reach second base in roughly 1.1 seconds. That means from the pitcher's initial move home to the catcher's throw arriving at second, 3.25 seconds elapse. Beating a good base runner by only a quarter of a second. That's less time than it takes to snap your fingers. Our question is, what factors can give the runner or the catcher an edge? For the base runner, it's all about the jump. If he takes off only 0.05 of a second too soon, he can get picked off. 0.05 of a second too late, and he loses almost 2 feet on the baseline. And for a catcher, it comes down to accuracy.
The main importance is an accurate throw. If you can't put the ball on the bag, then he's going to be safe every time.
For every foot the second baseman has to move his glove to apply the tag, the runner gains another 2 feet. That means from 128 feet away, the catcher's margin of error is roughly 1 degree. While stealing a base is spectacular, it's not always worth the risk. Studies that compare the potential loss versus gain of stealing a base have found that unless a player has a success rate greater than 75%, it's actually detrimental to the team to try it at all. For ESPN Sports Science, I'm John Brinkus.
So their numbers were a little bit different because I like mine a little bit better. I was doing a bit more research into it and stuff like that. I found the 2/3 number that you guys were saying is much more accurate than the 75% number. But yeah, stealing a base is really interesting. If any of you know the story behind the 2004 Boston Red Sox, they were losing 3-0 to the New York Yankees, and their entire series turned around on a stolen base. And you know what I'm talking about? You guys are lame. Anyway, It's an interesting story because the Boston Red Sox hadn't won in like 86 years or some junk like that. But that is besides the point. Again, I want to reiterate something before I show you something on Ricky Henderson. What you guys just did for me on these pages, the calculations that you were able to do, given the brief information, the conversion calculations, you are going to have to do something like that on what I'm going to be assigning you on Google Classroom. Distance equals rate times time. You're going to need to know how to use that in order to do the calculation on Google Classroom. The Pythagorean theorem, you're going to need to know how to do that. Now, being that you all are seniors, I'm going to assume that you all made it out of geometry. Okay. Out of geometry? Still? Juniors. I thought you were all seniors. Lame. Are there any sophomores? Aiden raises his hand. Yeah. Aiden, you a freshman? Sure? I think we should beat up all the sophomores.
We should. If anyone wants to vote for me, class president.
But if you're a sophomore and the only one, none of them can vote for you. Anyway. But yeah, these kind of calculations, these are the things that we're going to be doing on this assessment. Yeah. Yes, I did. Between Chewbacca and the Swedish Chef. Literally, it was that. You all know it was.
It's kind of funny.
Sure. Oh, goodness gracious. Back to this. Let's back to Ricky Henderson. Oop. Now. Who in the what? No, the debate moderator. My wife found something on Facebook to the effect of watching the moderator try to handle that debate makes you realize that kindergarten teachers need to be paid more money. So anyway, let's talk about Ricky Henderson. Now, I love the title of this video. Ricky Henderson crushed souls with unprecedented efficiency. Now, again, I just want to point something out here in terms of Ricky Henderson. Ricky Henderson was ahead of his time. In fact, check this out. Neither of them are Ricky Henderson. Let me show you something on this. Hold on. Check out this chart. Check out this chart. This is yearly home runs and yearly stolen base rates for each major league team, dating back to the year 1900. Now you can see when it gets to 1920, on the blue line, we enter what is known as the live ball era. And as a result, it skyrockets because more home runs are being hit. Obviously, Babe Ruth was the face of the 1920s live ball era. And then over the course of time, there have been various spikes, like in the 1950s when it was Willie Mays and Mickey Mantle, or in the 1990s when it was Sammy Sosa and Mark McGwire. There have been certain spikes, but over the course of the past 100 years, the number of home runs, or the home runs per game for each Major League Baseball team has gone up and up and up and up. But what has happened typically to stolen bases? Down, 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 down. Now, they used to be huge. People used to steal bases all the time. This was small-time baseball. That's what they did. It was strategy. There's a huge drop-off. And it's like, oh, I guess, But then, in the 1970s, right at the time, now, mind you, Ricky Henderson came in about right here. Came in right about here. But around here, there was kind of a revolution in terms of the number of stolen bases. Now, let me show you something, one more thing about the stolen base annual record before I show you the video on him. Something I found incredibly interesting. Annual leaders. Right. Now, check this out. In the 1970s, obviously, it was a bunch of different people here and stuff like that. Actually, let me skip to the National League real quick. Davey Lopes, Lou Brock. My goodness, Lou Brock. But anyway, look at this. In the 1980s, look how many times Ricky Henderson led the league in stolen bases in the 1980s. Now, you would think over the course of time, this guy would slow down. But he kept on leading the league in stolen bases. It was insane. It wasn't even a contest. Ricky Henderson, he was getting older and older and older, but he was getting better and better and better. And then eventually, they overtook him. Oh, here we go. Here's a bunch more that he won. And then in the 90s, Kenny Lofton took over as the best stolen base leader. But then at the end of his career, randomly, there's another Ricky Henderson. leading the league in stolen bases. How does this man do this? At that point, the dude was 20 years in the league. 20 years in the league, and he still led the American League in stolen bases. The dude is not human. Let's watch this video.
Alex, today we're going to do a very special episode of Door Town. This is the Ricky Henderson episode. And the special thing about this is, there's a lot of people who watch us who don't even watch sports, believe it or not. So you and I get to be the ones to tell them about Ricky Henderson. The honor of a lifetime. It's almost impossible to establish an unbreakable career record at this point in history. Baseball has just been around too long for that. Consider the all-time home run record of 762. Want to break it? Okay. First, you need to play at least 20 seasons. How likely is that? Well, in this 20-year span, 1,688 position players entered the major leagues. 16 of them ended up playing at least 20 seasons. So your odds of playing that long are less than 1%. Now that you've threaded that needle, the only thing you have to do next is hit 38 home runs in all 20 of those seasons. Do you realize how difficult that is to do even once? Let's stay in this same time span. Hitters played a total of 2,752 full seasons. 113 of them resulted in at least 38 home runs. That is about 4%. You have to make it to the top 4% every year for 20 years straight. Congratulations, you're still 3 short of breaking the record. You're going to have to come back at like age 42 and hit 3 more, I'm sorry. That's what it would take just to break the record by 1. There is no such thing as shattering a record like this. That's never going to happen. What does this have to do with Ricky Henderson? We'll get there. Here's the progression of the home run record.
Now, I just want to point this out because this thing, he's going to show a bunch of graphs, and I really want you guys to pay attention to this. This is the career home run record and the percentage by which it hits. Like, for example, today, in 2020, Barry Bonds has the record, and that's 100% of the record. He's completed the top 100% of the record by getting 762. Who is this? Who took the home run from roughly 15% of itself to almost 90% of itself from 1920 to 1930? Favorite? Yeah. The home run record at the time was like 100, and the dude took it over 700 by himself. Insane.
Throughout the entire history of baseball. In the 20s and 30s, Babe Ruth dragged the record to about 94% of what it is today. We've spent the last 80 years or so hacking away at the final 6% or so. That is generally how these records work, right? The hits record has barely moved since the Great Depression. Same with runs, same with RBI. The total bases mark hasn't moved since before I was born. It's very easy to look at this and conclude that we're very close to reaching the physical limits of how much a human being can do on a baseball diamond. That we've done the very best we can do. Now with walks, we can see a bit of a revolution. Barry Bonds heaped a full 20% on the all-time walks record, decades after you're supposed to shatter a record like that. But the real revolution, perhaps the greatest one-man revolution we can find in baseball's record books, belongs to Ricky Henderson. The stolen base record had barely moved since the 19th century. Thousands of players shuffled in and out of the box scores. Only Lou Brock could even make the slightest stand. And then, Ricky Henderson did that. A spike that dramatic just isn't supposed to happen at this point in baseball history. Too many players played for too many years for this to be happening. It's like drawing your name in a slab of concrete that was poured last month. But Ricky did it. Alex, we can't talk about Ricky Henderson without sharing some Ricky Henderson stories that may or may not be true. One of my favorites is it establishes that Ricky Henderson was kind of an alien. He didn't get a lot of things, not because he wasn't smart, because he was actually a genius, but he was just from another planet where things like money don't exist. Case in point, one time his team was, their record books were way off. They had $1 million more than they thought they were going to have. And they eventually find out the root of the problem. They call Ricky Henderson. They're like, hey, that $1 million check that we wrote you, did you cash it? It turned out he did not. He put it on his wall. He framed it.
I wonder what they use in his planet to exchange for goods and services.
When Ricky broke Ty Cobb's career runs record in 01, that was about par for the course for a guy who was always in scoring position, who loved scoring position, who lived in scoring position. But to get in scoring position, one must first get on base. This was easy for Ricky. As one of just 32 humans in the history of planet Earth with membership to the 3,000 hit club, his bat got him aboard plenty. And when it didn't, his patience and discipline consistently did from the moment he entered the bigs, drawing 117 walks his first full year, the youngest player ever to walk that much in a season. The next step would be swiping second, which, well, we all know Ricky enjoyed standing at first base about as much as Bobby Cox enjoyed calm, pleasant discourse with umps. With all these walks and steals, it didn't take long to make history. Before he even blew out 25 candles, Henderson already had 3 different seasons in which he both drew 100 walks and stole 100 bases. Since 1900, every other MLB player has combined to give us 0.
I just want to point that out. 100 walks, 100 stolen bases. It's only been done 3 times in the over 100-year history of baseball. And they only belong to Ricky Henderson. He's the only guy to do it. That is insane.
Of those 100 seasons. So as you might have guessed, for his overall career, the frequency with which he'd reach base and steal his way to more is unprecedented. Feels like we ought to take a look at MLB's all-time leaderboard for most times getting on via hit or walk with stolen bases thrown into.
Yeah.
We see that not only is Ricky King here, all the way at the top with over 6,600 of them, but only Ty Cobb, Pete Rose, and Barry Bonds are even in his ballpark. No one else is within 1,000. For perspective, in 2017, Joey Votto led the majors with 318 hits plus walks plus stolen bases. That means Eddie Collins, even with being top 5 on the all-time list, would still need to tack on nearly 3.5 MLB-leading Votto seasons just to bridge the gap between he and Henderson.
Here's another one. Ricky played here in New York City for a while. He played for the Yankees. And upon getting a home here, he was so proud of his new condo. He was telling all his teammates about it. And he bragged that he could see the entire state building.
Come on, Ricky.
That's pretty good, right? Yeah, no, it's actually true. Y'all remember Stratego? That board game where you had to send your army to find your enemy's flag? The whole game hinged on the fact that you didn't know where the flag was. I remember there was a kid in my neighborhood who was so good at this game and so overconfident that he would always turn his flag around and say, "Here,
I can't
here's
hear,
a flag.
I can hear them.
Try to get it." And he would still win. That was Ricky Henderson on the base paths, especially in 1982. That season, he had 225 stolen base opportunities. In other words, he was on either first or second, and the next base was open. He attempted 172 steals, so in effect, if you were a pitcher who gave Ricky a chance to steal, he would do so about 3/4 of the time. Now, usually stolen bases rely on the element of surprise, right? But Ricky used the threat of a stolen base as a weapon, as if to say, "I am going to steal. There is nothing you can do about it." It seems reckless, but it's not reckless if you're good enough. He'd just steal until he got caught. This figure is just a little bit inflated because it doesn't account for the times Ricky stole multiple times in a single trip around the bases. In 1982 alone, there were 19 times in which he stole second and then turned around and stole third on the same trip on the base paths. Ricky was one of the most resourceful athletes I have ever seen. He was an expert at making something out of absolutely nothing. He demonstrated this masterfully on June 8, 1982 against the White Sox. In the 5th inning, he lucked into first thanks to an error by the third baseman. The guy behind him hit a single. Ricky managed to stretch himself all the way to third on that hit, which, by the way, is another of his talents. Going from first to third on a single is often pretty tough to do, but throughout his career, Ricky made it to third almost half the time. Anyway, right after that, Ricky steals home. Fast forward 2 innings later. Ricky gets hit by a pitch and sent to first base. Then he immediately steals second. Then he immediately steals third. From there, all it takes is a single to send him all the way home. Within 3 innings, Ricky Henderson had turned an error and a beanball into 7 bases. Ricky was an alchemist.
So he threw left-handed and he batted right-handed. Now, there have been over 800 players in the live ball era with at least 5,000 career plate appearances. He is the only one to do that.
Okay, throwing left-handed, I understand. But
don't understand how y'all right-handers do stuff right-handed. It's so weird. Whenever I watch you guys write, it's like, how do you even write right-handed? I don't get it.
What also makes Ricky's 1982 season so transcendent is how he stacked up within the context of the American League. Upon conclusion of that beautiful 3-steal game in Chicago, Ricky's total for the season had risen to 57, literally tripling any other AL player with no one else even at 20 yet. He could have just kicked his feet up right then in early June, gone on sabbatical for the rest of the year, and he still would have led his league in steals for the season, after taking the final 105 games off. Fast forward to near the end of the season, and before missing some time over the final couple weeks, Ricky woke up on the morning of September 12th with 124 steals. Cleveland was the lone AL team to have stolen that many. It was more than Baltimore, Boston, and Minnesota combined. Minnesota in particular is worth a deeper dive into how they stacked up against Ricky, because that's where it gets really weird. So at this point of the year, the Twins had completed 87% of their season. They were sitting there with a total of 32 stolen bases. At the same point in time, let's check how much Ricky Henderson had stolen just third base. And would you look at that? It's 33. That year, less than 1 out of 10 stolen bases were at third. And yet here we stood in mid-September with one man having stolen just that base, more than an entire team had stolen any base. That is Ricky Henderson for you.
So I think what we've learned is we could go on a very long time about Ricky Henderson. It's really tough to name a more interesting baseball player than Ricky Henderson. When you say,
Other than Adam Dunn, yeah.
It's Adam Dunn, number 2, Ricky Henderson.
Yeah, they have a whole thing about Adam Dunn, which is very weird. I'm not going to get into the details of that. Last thing I want to do today, I want to talk about this. Now, I'll just leave that there. There we go. I want to talk about this. Now, the other class has a little catching up to do. The other class tomorrow, we're going to have to catch up with the first round matchup because I was out that one day. But you guys get to determine the winner of Barry Bonds versus Willie Mays. You know the interesting thing about the family connection between Barry Bonds and Willie Mays? Anybody know it? They're not actually related by blood. Do you know? No, they're not related by blood. Willie Mays played part of his career with Bobby Bonds. Bobby Bonds. Willie Mays is actually, I think, either his godfather or like someone like in that kind of realm or something like that. It's really weird the way that works out. Because Barry Bonds was born in the 1960s when Willie Mays was still playing. Very weird. The Giants are very weird, man. The Giants won the World Series, 2010, 2012, 2014. Do you know the last time the Giants won the World Series before 2010? It was the only World Series that Willie Mays ever won. It was 1954. Anywho, back to this. Barry Bonds versus Willie Mays. I had you guys switch. We have a little bit of time. We're going to take a vote in a few minutes. Give me some information on either player, positive or negative. What do you got? Give me some information on Barry Bonds or Willie Mays. I know you guys have sent me a bunch of stuff, and I've been looking at that, but I want to know what you got now. Go.
Willie Mays,
24-time All-Star. Again, just, consistency, things of that nature. May not speak to his home run hitting ability, but it definitely adheres to his durability.
14 seasons and being in the top red
For Mays?
Yeah.
So 14 seasons, say it again?
14 seasons in top 10 home runs.
14 seasons, he was top 10 in home runs, which is pretty sick, to say the least. Like being in one of the top 10 home run hitters in the entire league for over 14 years, that has to be like at least, I don't know, what do you have to hit to be in like the top 10, like 40 home runs or something like that? It's insane. Like that many seasons right there, like 14 seasons. What's 14 times 40? It's got to be over 400, 500 home runs or something like that. It's insane. Go ahead. Bonds still has 762. How many did Mays have? 660. He just had 660. Keep going. Who did? Bonds. What's his OPS?
It's like 1.1.
Let's Google it. Hold on, I'll look it up. Barry Bonds career MLB. Hold on, I got it. I mean, I'm almost there. I got 5 minutes. We got time. His career OPS was 1.051. Well, single season, he would definitely have. Mind you, his OPS. We watched that one video on. Yes, which was over 1.2. He's the only guy. He had 4 seasons with over 1.2 OPS. Let me look at career. Hold on. What was his? He has a slightly lower what? What was it? His OPS was 0.941. Which again, OPS didn't exist back then, but they still had the numbers to calculate it. Did Bonds? Oh, so he was a part of the all-time team. Bonds did do drugs. He did PEDs, performance-enhancing drugs. Mays was Rookie of the Year. Bonds wasn't.
Mays had 14 seasons in top 10 slugging percentage as well.
So not only home runs, but also slugging and runs scored. Interesting. Now I'm trying to look up the number that Aiden was talking about for Barry Bonds. What was that number again?
It was like
0.863?
Yeah,
that was his slugging percentage in one season.
Yeah, Brian was right.
Yeah. Which, mind you, that slugging percentage was the year that he hit 73 home runs.
Yeah, I did that too.
73 in a season. What was the highest Mays ever had in a season?
68.
You're just making up a number now.
I didn't do Mays.
I know.
You know what thing we had to do with the players with our first name?
Yeah.
I did that, and for one of the things, like one of the equations we had to do,
Yeah.
I got an answer, and then MLB.com got an answer, but my answer was right, and their answer was wrong.
Send me a note and I'll take a look at it.
It was like,
Hold on. Stay there. Anyway, the highest number of home runs. Hold on. The highest number of home runs that Willie Mays ever hit in a season was only 52. The highest he ever hit was 52 in a season. 52 in a season. See, the interesting thing is Bonds is actually a part of something called the 40-40 Club. You know what that is? Home runs and stolen bases. There's only 4 people in the 40-40 Club in the history of baseball. 4. And Bonds is one of them. Let's take a vote. It's just a hand vote. I said a hand vote. Raise your hand if you believe that Bonds should be the one moving on. Hold on. Keep your hands up if you're going to vote for him.
Bonds it is.
That is more than half the class. I was going to say 1, 2, 3, 4, 6, and it would have been 6-3, and if even went the other way, it would have been 6-4, something like that. Okay, you guys are saying Bonds over Willie Mays. Yeah, I'm just saying. Personally, I would probably disagree, but you guys are voting for Bonds, so Bonds is moving on.
I got 8.90.
Are you sure it didn't change because he played more games?
I don't know.
You got to look that up.
Look it up right now.
I can't look it up right now because I got another class coming in. So for those of you in the chat, we're going to sign off now.
Oh my god. I need to know.
End that there.
Look it up on your own.